Welcome to Brain Vision.
Now we want to eventually find the acceleration of the block, but the acceleration depends on the net force acting on the block. So we'll have to first find what is the expression for the net force based on the potential energy function. That is the force. Right, the expression of the force is equals to negative du dx for the I direction, and also negative du dy for the j hat direction, since this is the y direction. So from our expression of the potential energy, you should be able to get negative 5.8 times 2, which should leave us with 11.6. 11.6 joules per meter square times x. This is for the I direction. Then for the y direction, get positive just get positive 10.8 joules per meter cube times y square. This is in the j hat direction. Now we are given a particular point that we want to look at. So x is equals to 0.3 and y is equals to 0.6. We substitute that into our expression for the force. We should get negative 3.48 newtons in the I direction and positive 3.89 newtons in the y direction, which is the j hat direction. Now the net acceleration, we need to find the net force, which is taking the overall magnitude of this, which is just taking the x square plus the y square square root. So this is the magnitude of the force, and from here we can find the net acceleration magnitude by dividing by the mass, which in this case is given as 0.04 kilograms. And this leaves us with 130 meters per second square. So this is the net acceleration. But to get the direction, we can use an angle to find what is the direction. So the angle we can find with respect to the x-axis. So since we have negative x and positive y, the direction should be in this. The direction of the force should be in this direction. What is this angle that we want to find? We know that the magnitude of the x component of of our force, which is over here. X component is this value. The Y component is this value. So in order to get the big angle over here, we can get the small angle inside, and then we take 180 degrees minus the small angle. So the small angle basically is a tangent inverse of the 3.89 divided by 3.48. This gives us 48.2 degrees. And so taking 180 degrees minus this value, so theta is 180 minus 48.2. So this leaves us with 132 degrees. And so the direction of the magnitude of the acceleration is 130 meters per second square with an angle of 132 degrees from the positive x-axis.